For decades, the hydrogen car has existed in a strange place inside the automotive world. Every few years, a new prototype would appear. Executives would stand beside futuristic concept vehicles. Headlines would claim hydrogen was about to revolutionize transportation. Then reality would arrive. Infrastructure was too expensive. Hydrogen was too costly. Fuel stations barely existed. Battery vehicles moved faster. And the entire conversation would fade back into the background again. That cycle repeated so many times that much of the public stopped taking hydrogen mobility seriously at all. But something different is happening now. Quietly, almost invisibly. Because the latest hydrogen move from BMW Group and Lhyfe is not behaving like a normal hydrogen announcement. There are no flashy concept vehicles dominating the story, no exaggerated promises about millions of hydrogen cars suddenly appearing on roads next year, no science fiction marketing campaign trying to convince the public that the future has already arrived. Instead, what we are seeing looks much more industrial, much more operational, much more serious. BMW has selected Lhyfe as a supplier of green hydrogen for its Steyr Research and Development Center in Austria, where the company is preparing fuel cell systems and hydrogen propulsion technologies for future production. On the surface, that sounds like a standard supply agreement. But under the surface, this announcement may reveal something far more important about where the hydrogen economy is actually heading. Because this deal is not really about cars. It is about whether hydrogen can survive contact with industrial reality. That distinction matters enormously. For years, the hydrogen economy was dominated by projections, press releases, and giant future capacity announcements. Companies announced gigawatts of electrolyzers before securing electricity. Ports discussed ammonia exports before pipelines existed. Governments announced national hydrogen strategies before off-take agreements were finalized. Entire market valuations were built around future assumptions instead of operational systems. But industrial systems do not care about announcements. Industrial systems care about reliability. Can hydrogen arrive on time? Can the supply chain function consistently? Can purity standards be maintained? Can logistics survive under real operating conditions? Can utilization remain high enough to make economics work? Can the infrastructure operate without massive subsidy dependency? Those are the questions that determine whether hydrogen survives beyond the PowerPoint phase. And this BMW Lhyfe agreement sits directly inside that transition. Because the hidden signal here is not the fuel cell itself. Fuel cells already work. Hydrogen engines already work. Hydrogen trucks already work. Hydrogen buses already work. The engineering question was never the real bottleneck, the system was. And BMW appears to understand that very clearly. The Steyr facility is not simply a research laboratory disconnected from reality. This is a center focused on industrialization, validation, manufacturing preparation, and propulsion system development. BMW is preparing what it calls its next-generation hydrogen propulsion systems, with plans targeting production later in the decade. That changes the meaning of the hydrogen supply agreement completely. Because once a company moves from laboratory experimentation toward industrial preparation, the requirements become much harsher. Hydrogen suddenly stops being a theoretical energy carrier and becomes an operational dependency. If deliveries fail, testing fails. If purity fluctuates, validation becomes unreliable. If logistics become unstable, manufacturing timelines become unstable. If costs remain too high, the entire business model collapses. This is why Lhyfe matters in this story. Most people still think the hydrogen economy is mainly about electrolyzers. But increasingly, the real competitive edge in hydrogen is not just producing molecules. It is moving molecules reliably through an industrial system. That is much harder and much less glamorous. Lhyfe has been building operational hydrogen delivery networks across Europe, rather than simply announcing future ambitions. That operational layer is becoming one of the most important hidden battlegrounds in the hydrogen economy. Because hydrogen is not like software, you cannot scale it infinitely through code. Hydrogen is physical infrastructure. Every kilogram requires electricity, water, compression, transport, storage, safety systems, permitting, logistics coordination, and utilization planning. And every single one of those layers introduces friction into the system. This is where many hydrogen projects begin to break down. A hydrogen plant may technically function perfectly while the business itself still fails economically. Why? Because the electrolyzer was never the entire system. The hidden costs live everywhere else. Transport costs, compression costs, interconnection delays, power pricing volatility, low utilization rates, maintenance complexity, certification compliance, storage infrastructure, distribution bottlenecks. Hydrogen economics are extremely sensitive to system utilization. A project designed around high operating hours can become financially unstable if electricity availability drops or demand becomes inconsistent. Suddenly, the cost per kilogram rises dramatically. Financing assumptions begin collapsing. Investors lose confidence, timelines slip. That is why the hydrogen market is increasingly dividing into two categories. The first category is hydrogen as a headline. The second category is hydrogen as infrastructure. The first category gets attention. The second category survives. And what BMW appears to be testing with Lhyfe is whether a hydrogen infrastructure ecosystem can function reliably enough to support industrial deployment conditions. That is a far more important milestone than simply launching another hydrogen prototype vehicle. Because infrastructure determines survivability, and survivability is becoming the real competitive edge in clean energy. This is especially important in Europe right now. Europe is entering a period of energy system stress that changes the hydrogen conversation dramatically. Grid congestion is increasing. Industrial electricity competition is intensifying. Permitting delays remain severe. Power prices continue fluctuating. Heavy industry faces decarbonization pressure while simultaneously trying to remain globally competitive. Under those conditions, hydrogen becomes less about replacing every battery vehicle and more about solving specific industrial constraints that batteries struggle with. That is a completely different framework than the one the public usually sees. The public debate often frames hydrogen versus batteries as a winner-take-all battle. But industrial systems rarely work that way. Different systems optimize for different constraints. Batteries are extremely effective for many applications. But they also introduce challenges involving charging infrastructure scaling, raw material supply chains, grid load management, charging times, and high utilization operational cycles. Hydrogen introduces different trade-offs. Refueling speed, energy storage flexibility, long duration operation, high utilization fleet applications, potential integration with industrial hydrogen demand. But hydrogen also introduces its own massive infrastructure burdens, which is why BMW's approach matters here. BMW has repeatedly avoided positioning hydrogen as a total replacement for batteries. Instead, the company frames hydrogen as part of a broader technology portfolio. That strategy may appear indecisive to some observers. But under system stress, diversified technological positioning can become extremely valuable. Because the future energy system may not optimize around a single perfect technology. It may optimize around resilience. And resilience often comes from system diversity. This becomes even more important when you look at Europe's broader industrial situation. Europe is attempting simultaneous decarbonization, electrification, industrial competitiveness preservation, and energy security restructuring, all while facing geopolitical instability and infrastructure constraints. That is an extraordinary systems challenge, and hydrogen increasingly sits inside that larger puzzle. Not as a miracle solution, but as a strategic industrial tool. That subtle distinction changes everything. For example, one of the hidden implications of the BMW Lhyfe partnership is that hydrogen mobility could become increasingly connected to industrial hydrogen ecosystems rather than standalone public fueling networks. That is a very different deployment pathway. Instead of building massive nationwide hydrogen station networks immediately, hydrogen systems may initially grow around industrial clusters, logistics corridors, heavy-duty fleets, ports, and centralized utilization hubs. That model potentially improves utilization economics because hydrogen demand becomes concentrated rather than scattered. And concentration matters enormously in hydrogen economics. Low utilization destroys infrastructure profitability. High utilization improves survivability. This is why many of the strongest hydrogen projects globally are increasingly tied to industrial ecosystems rather than consumer transportation alone. Ports, steel plants, ammonia production, chemical facilities, heavy transport corridors, industrial heat applications, integrated energy hubs. The hydrogen economy may not emerge first through ordinary passenger cars. It may emerge through invisible industrial systems operating underneath the economy. And that possibility makes the BMW Lhyfe story far more significant than it initially appears. Because this agreement reflects operational integration, not just technological experimentation. And that transition from technology demonstration toward operational integration is one of the hardest phases in any industrial transformation. History repeatedly shows this. Many technologies function technically long before they become systemically viable. The real challenge is integration. Railroads, electric grids, natural gas systems, internet infrastructure, air transportation, container shipping. All of these systems required decades of infrastructure layering before they became economically dominant. Hydrogen faces the same reality, which is why the current phase of the hydrogen economy is so dangerous for many companies. The easy phase was announcing projects. The hard phase is surviving execution. Can companies maintain financing through delays? Can infrastructure be completed before subsidies expire? Can utilization remain high enough? Can logistics operate profitably? Can power remain affordable? Can supply chains scale? Can industrial customers commit long-term? That is the real hydrogen market now. And that market is becoming far more brutal than many early investors expected. In fact, the hydrogen economy is increasingly transitioning from a hype market into a survivability market. That means the winners may not necessarily be the companies with the biggest announcements. The winners may be the companies that can actually maintain operational continuity under difficult economic conditions. And operational continuity is precisely what this BMW Lhyfe agreement is testing. Can green hydrogen be delivered consistently enough to support industrial automotive development? That sounds simple, but it is not. Because industrial systems punish inconsistency brutally. A missed hydrogen delivery inside an industrial validation environment is not a social media problem. It is a manufacturing problem. And manufacturing systems are unforgiving. This is also why the logistics layer may become more valuable than many people realize. Everyone talks about electrolyzer capacity. Fewer people talk about hydrogen distribution reliability. But distribution reliability may ultimately determine which hydrogen ecosystems survive. Because hydrogen has very low volumetric energy density. Transporting it efficiently is difficult. Compressing it requires energy. Liquefaction is expensive. Storage infrastructure is costly. Pipelines require enormous investment. Hydrogen punishes weak infrastructure design, which means infrastructure quality becomes a strategic advantage. And this may explain why partnerships like BMW and Lhyfe matter more than giant speculative announcements. Because they involve operational trust. BMW is not simply purchasing hydrogen molecules. BMW is testing whether an external hydrogen ecosystem can support industrial reliability requirements. That is a far more advanced stage of market development. At the same time, this does not mean hydrogen has already succeeded. Far from it. The risks remain enormous. Hydrogen passenger vehicles still face severe challenges. Battery technology continues improving rapidly. Charging infrastructure continues expanding. Hydrogen refueling infrastructure remains limited. Electrolyzer economics remain difficult under low utilization. Renewable electricity competition remains intense. And many hydrogen projects globally continue struggling financially. That reality is important. Because one of the biggest mistakes in clean energy analysis is assuming that technological functionality automatically guarantees economic dominance. It does not. The world is full of technically successful technologies that failed economically. Hydrogen still must prove it can survive under real market conditions without permanent subsidy dependence. And that question remains unresolved. But what is changing now is the nature of the hydrogen conversation itself. The market is becoming less interested in futuristic promises and more interested in operational evidence. That is healthy, because mature industrial sectors are built on reliability, not excitement. And reliability is boring. It involves delivery schedules, compression systems, transport contracts, industrial standards, maintenance protocols, utilization optimization, grid integration, safety procedures, certification compliance. All the invisible systems nobody talks about on social media. But those invisible systems are where industrial revolutions actually happen. And BMW's partnership with Lhyfe may represent one of those subtle early indicators that hydrogen is beginning to move deeper into that industrial reality phase. Not because the public suddenly fell in love with hydrogen cars, but because industrial players are testing whether hydrogen systems can survive operational stress. That is the hidden story. Not hype, not futuristic renderings, not speculative trillion-dollar market projections, system survivability. And that may become the defining theme of the entire next chapter of the hydrogen economy. Because the companies that survive this phase will likely look very different from the companies that dominated the announcement phase. Execution will matter more than vision. Infrastructure will matter more than prototypes. Utilization will matter more than nameplate capacity. Reliability will matter more than marketing. And industrial partnerships like BMW and Lhyfe may ultimately reveal where the real hydrogen economy is quietly forming beneath the surface. Not in headlines, not in concept vehicles, but inside the invisible infrastructure systems that determine whether industrial civilization can actually decarbonize without breaking itself in the process. That is why BMW choosing Lhyfe for green hydrogen is not really about cars. It is about whether hydrogen can finally transition from technological possibility into industrial survivability. And in today's energy economy, those are two very different things.